Triangles. Now let us move on to a very important topic, that is basic proportionality theorem called as BPT and its converse. So first of all, let us concentrate only on BPT, that is basic proportionality theorem. So here is the statement. If a line is drawn parallel to any side of a triangle, intersecting the other two sides in two distinct points, then it divides the sides in proportion. So if a line is drawn parallel to any side of the triangle, so again we need a triangle. If a line is drawn parallel to any side of the triangle, so we need a triangle. So this is a triangle. Let me name the triangle now. Suppose this triangle is triangle ABC. So we have the triangle now. If a line is drawn parallel to any side, so I have to draw a line parallel to any side. Suppose I select the side BC and I have to draw one line parallel to BC. But how is that line? That line is intersecting the other two sides, that is AB and AC, into distinct points. Distinct means different points. So let us see how the line will be. So let me draw a line. So this line over here, you can say intersects AB over here and it intersects AC over here. So these are the two distinct points that we got. Now this line, suppose this line is a line L, intersects AB and AC in two distinct points. Let me name the two distinct points A and F. What they're saying is, then this line, that is, we can say that this EF divides AB and AC in proportion. Proportion means AB upon supposed to prove. Before proving that, we'll start with the given part. So what's given over here? It is given that in triangle ABC, so it is given in triangle ABC, line L is parallel to BC. So line L and BC are parallel. Given, you can say what we are supposed to prove. We are supposed to prove something. So we will write down to prove that this line L divides AB and AC in proportion. That is, we can say that AE upon EB is equal to AF upon FC. So this is what we are supposed to prove. So to prove this, we need to do one construction. Let me write down construction over here. The construction over here is, we are supposed to join BF, first construction, then we are supposed to join EC. BF and EC we have joined. This is the first construction, first and second construction. One more construction is there. So the construction as of now is join EC and BF. Then the construction is draw EM, draw EM perpendicular to AF and draw FN perpendicular to AE. So this is the construction part, slightly complicated. We'll write down join EC and FB, first construction. Then draw EM perpendicular to AF. Draw EM perpendicular to AF. And draw FN perpendicular to AE. So FN perpendicular to AE. So in given we got the triangle ABC is there, line L is parallel to BC, then we have to prove that AE upon AB is equal to AF upon FC. Then in construction, we have joined EC and FB, we have drawn EM perpendicular to AF, FN perpendicular to AE. Now we'll go to the proof. We're just continuing with the proof. So to prove this, first of all, what I'm doing is I'm considering triangle AEF. Just concentrate on triangle AEF. AEF. Just look at the pencil cursor AEF. So I can say area of triangle AEF. We're talking about area as of now. See how we are going to prove this. Area of triangle AEF. What is area of triangle? Area of triangle is half into base into height. So if I select AE as the base, NF will be the height. If I select AE as the base, NF will be the height. So area of triangle AEF will be half into base. I'm taking base as AE. So I can write down half into AE into, I'm taking height as FN. I'm naming this as statement 1. So what we did, we found out the area of triangle AEF. So area of triangle AEF is half into base into height. Base is AE, height is FN. So half into AE into FN. Now I am selecting triangle BEF. So just observe the cursor BEF. So area of triangle BEF. Again, area of triangle is half into base into height. Now observe this triangle BEF is something like this. Now this is the base. B is the base because we have B over here. We have E over here. And this angle is an obtuse angle over here, this one. So the height will lie behind. So this is the height for this triangle. The height will be behind. That means if B is the base, Fn is the height. B is the base, Fn is the height. So it is again going to be half into base into height. So half into base is going to be BE and the height is going to be Fn. We got this as equation 2. So we have equation 1 and equation 2. Now what we can do is we can divide both the equations. So let us divide both the equations now. If we divide them, we are going to get area of triangle AEF upon area of triangle BEF is going to be, I'm dividing 1 and 2. So here I have to divide. So here also I need to divide. So in the numerator I have half into AE into Fn, and we have in the denominator half into BE into Fn. So what is going to get cancelled? Half and half will get cancelled. Fn and Fn will get cancelled. Ultimately, you are going to get the result as AE upon BE. So we got AE upon BE. Now this result is when I did area of triangle AEF divided by area of triangle BEF. I got AE upon BE. Now what I'll do is I'll take triangle AEF. So let me write down this result somewhere. So this is the result that I'm having as of now. Area of triangle AEF upon area of triangle BEF is AE upon BE. So I'm just writing down separately. So I'm writing down this result over here. That area of triangle AEF upon area of triangle BEF is equal to AE upon BE. Let us name this result as our result 3 that we got. Let me name this result as our result 3 which we got after dividing result 1 and 2. Now let us move on further. So further what I'm doing, again I'm taking triangle AEF. Again if we take area of triangle AEF. Area of triangle as we know is half into base into height. Now this time I'm taking the base as AF. So EM will be the height. So we have half into base AF into height. That height is EM now. Let me name this as result 4. Now I'm taking triangle EFC. Now I'm taking triangle EFC. So just look over here. I'm taking FC as the base. Again, this is obtuse angle, so the height will lie behind. So EM will be the height. So we have now area of triangle EFC will be equal to area of triangle EFC will be equal to half into base into height. Base, the base is FC into height. Now the height is EM. Now the height is EM. I'm naming this as result 5. Now what I'm going to do is again I'm going to divide. So let me divide them. So let me divide them. Let me divide area of triangle AEF upon area of triangle EFC. Area of triangle AEF upon area of triangle EFC will be equal to divide half into AF into EM, half into AF into EM upon half into FC into EM. Half will get cancelled, EM will get cancelled. Ultimately we are going to get the result as AF upon FC. What I got now, now this term, that is this area of triangle AEF and this area of triangle AEF is same. That means they two are equal. Now observe this triangle EFC and triangle BEF. We have like this EFC. Triangle EFC is like this. Between the two parallel lines EF and BC, between the two parallel lines EF and BC, similarly, triangle BEF is like this. Again, between the two parallel lines EF and BC, EF and BC. So what we learned in class 9 as well, that in areas of parallelograms, in chapter of area of parallelogram, that triangles having same base, the triangles having same base and between same parallels have equal areas. Triangles triangles having same base and between same parallels have equal areas. So both these triangles have same base EF and EFC also has base EF, and both of them lie between two parallels EF and BC. Therefore, these two areas are also same. Therefore, these two areas are also same. That is, the LHS is same now. Therefore, we get RHS equal. So we can say that AF upon FC is equal to AE upon BE. So this is proved basic proportionality theorem that AE upon is equal to AF upon FC. That if a line is drawn parallel to any side of the triangle intersecting the other two sides in two distinct points, then it divides the two sides in proportion.